I'm not even the expert. Usually
Okay, Dan reminds me to review the moderation rules for papers. Good call. So the speaker has 10 minutes to speak. They will be giving a gentle 2-minute warning at 8 minutes in, and then a firmer warning at 10 minutes. And then I will pass the microphone for questions. Please do let the microphone get to you before you ask the question so that it can be recorded and on our live stream.
Okay, I guess it's there's like an objective timer system this year if you haven't done a paper, so it's like really rigid. So, good morning. Welcome to my paper on processing storytelling with Gaia DR2 data. This was written by me and my coworker Milan Bach, who is one of our engineers at the Academy of Sciences, and unfortunately will have left the Academy by the time I get back. He's an incredibly valuable asset, but we will have a job opening in our engineering department. Just to let you know. I'm also doing this paper for my mom's high school class next week, so I'm going to skip over some basics. I assume you guys are familiar with constellations, and significantly are familiar with the basic idea of proper motion, that stars move through the universe across time. And perhaps you have even simulated proper motion in your planetarium. Significantly, most of the proper motion data we have comes from a single satellite mission, the Hipparcos satellite, launched by the European Space Agency in the 1990s. The Hipparcos satellite and its derivative catalog, XHIP, the extended Hipparcos catalog, is pretty much the basis for the 3D stellar simulation used in almost all folded planetarium software. But it's not a perfect solution. Hipparcos only got good measurements for about 118,000 stars, which sounds like a lot when you consider we can only see like 6,000 with the naked eye. But when you consider there's hundreds of billions in the Milky Way, not so good. Also, its proper motion measurements are quite incomplete. So if you look at Rigel in particular, Rigel's not moving at all, and it probably should be. A lot of stars in Hipparcos just didn't have proper motion measurements. So, enter Gaia, another ESA mission launched 5 years ago, basically to be a successor to Hipparcos with the goal of measuring basically all the stellar photometry and proper motion and position for about 1.2 billion stars total. It's at L2, but I assume you guys know what L2 is. That's for the high schoolers. I also assume you know what parallax is. Hipparcos, like Gaia, like Hipparcos before it, is using parallax to make the measurements of stellar distances. And the result, published by ESA, is something that looks like this. You can make an all-sky map out of this. This is the density coverage map, so it shows you where Gaia measured stars. And it does a really good job of outlining our Milky Way galaxy, because stars concentrate along the galaxy, as well as large and small Magellanic Clouds, things like that. It is, picking up light sources outside of the galaxy too. It also is doing photometry, so it's giving us color information of the stars. This map is cool. It's not necessarily as useful for us as a planetarian as expected, because it's basically color-coding stars on just are they redder or are they bluer. It's not precise, accurate color values, but it's still pretty cool. And also really cool is, of course, Gaia gives us really good detail on the dust of the Milky Way, because it is a visible telescope. It is not infrared, so it can't see through dust. So you get these really beautiful dust maps out of it too. But 2D all-sky maps aren't the most useful thing for us. I mean, they're useful for planetariums. But the coolest thing about this data is it's not just 2D data. It's 3D data, because Gaia is measuring the distances to stars. And of course, because it's measuring proper motion too, it's really 4D data. It's measuring positions in space and time. Ooh. So, if you make a Gaia data request, this is what it comes down looking like. Which hopefully, if you've ever worked with stellar data before, this is not unfamiliar. It's, you can of course get it as a CSV or a binary fits file, but yeah, you can actually read the photometry data for stars and process it. So you have to do a lot of filtering, of course, to make it useful, because there are a lot of measurements. Not all of them are necessarily useful in the planetarium. And it's also a huge data set. Even the early releases were millions of stars, and when the final, well, the data release too, not the final data set, when the current one is over 1 billion sources, it's a lot of work to do and a lot of data to churn. So originally we weren't going to do anything with it for a while. We sort of mapped out a workflow. If you are or know any programmers, everyone always recommends like, oh yeah, map out what you want to do on paper first. And I feel like people never really do that very well. But this was such a big project, we did map out how we're going to handle this, and especially because Gaia is a lot of stars, but it's not complete. A lot of the bright stars that are familiar to us in our night sky, like say Sirius, are not currently measured by Gaia. So Gaia isn't just a drop-in replacement for Hipparcos. There's a lot of data merging and cleaning that has to be done to make it useful. So I started working with subsets of the data in Excel. I just want to say Excel is the wrong way to do this, but I like to start with it because I can make sure I'm doing the right thing each step of the way. And I mentioned, yeah, we weren't going to do anything with it for a little while, but Dr. Jackie Faraday from the American Museum of Natural History contacted us and asked us if we were interested in working on some subsets of the data, and I try to never say no to her because she's really, really nice. And just a cool researcher. So she sent us some subsets. I started working with them in Excel to make sure I could do all the conversions right, because the biggest thing is the measurements from Gaia are in spherical coordinates, and we have to do the work to move them into Cartesian coordinates. And if you were in Mark's workshop yesterday, basically this job shouldn't be as hard as it is. We should all be able to just easily ingest things into our systems without doing that. That's not the world we live in yet. And of course, not just doing the Cartesian conversion, but also specifically converting proper motion from spherical proper motion measurements to Cartesian proper motion measurements, which you might notice is a matrix transformation. And part of the reason I'm giving this to my mom's high school class is I didn't do so great on matrices in high school. So I'm supposed to tell her math students that, like, even if you're not good at math now, you might still have to use it. With some help, I was able to break it out into linear equations that I was much better with. And then, we got successful tests out of these Excel subsets. But Excel can't handle a lot of data. If you've ever tried, it gets overloaded really easily. So this was basically our test case, and then working with my colleague Milan Bott, that's when we used AstroPy to do the rest of the work. Because all these things that are these super long formulas that you just saw are like one command in AstroPy. So I just wanted to make sure we could get the right result, and then that the two results would be consistent between each other. So with AstroPy, we could process a lot more data, but we still needed a really powerful machine. We did do a subset of Gaia. We threw out all stars that didn't have luminosity measurements, basically, because UniView relies on those to draw the stars. If we didn't have one, it wasn't any good, so that reduced it to about 58 million stars, although we found out we had a timeout. It actually should have been 72. It crashed our computers when we ran it at first. Specifically, a computer with 64 gigabytes of RAM, so we had to do some work to get it to load and unload into memory. But then we got stars. This is going to be a 100 parsec subsample. So that was Hipparcos fading out, Gaia fading on, slightly brightened. And yeah, in the 100 parsec sample, we have about 500,000 stars, which is pretty cool. And in the 58 million star sample, you can see just how much of the Milky Way it covers. Like, this is totally changing our perspective on the 3D universe. And this is where we start to get into the storytelling. Like, just loading a 72 million star data set isn't giving you anything useful. You have to tell stories with it, especially because loading this up takes 12 gigabytes of RAM in UniView and probably most other software, so like there need to be more efficient handling systems come up with. And the biggest thing to do is like, you gotta figure out ways to subset it to make it useful. Another cool thing, you can't really see it in the projected image, but hopefully you'll see it in my paper images. Because it's 3D and has so many measurements. Yeah, oh, great. You actually get like this amazingly detailed view of the Milky Way without a photographic background. So that's real dust lanes of the Milky Way because of course it can't see through it. So it's like this opens up a new world of like we could make better background Milky Way simulations, even in 2D. Yeah, here's another 2 million years of stellar motion. You guys know that. It's much more complete than Hipparcos, of course. So the main thing we subset Gaia to use at Cal Academy, based on Faraday's research, are moving groups. So some familiar constellations, and of course, as planetarians, I assume you know that the Hyades and Pleiades are actually two moving groups. They're stars that move together because they're still relatively recently close to the cluster they were born in. and so they move across space together. And one of the great things you can do with data like Gaia is you can just churn through data and find moving associations of stars. There are both large groups like the Pleiades and Hyades that are still relatively young clusters, but also pairs or triplets of stars. And as Faraday would say, and as the paper shows, a lot of these are, when you see two stars move together like a binary or triplet, they're probably still the remnants of a cluster, but as clusters pass by each other over millions, billions of years, they eject stars, they get broken apart, and only little cores are left. So you can learn a lot about stars by studying clusters. Is this gonna work? Come on, video. Here it is in 3D, a little bit slower. But a cool thing about Gaia is it can be used to discover new clusters that were unknown before. So there's some very recently published research by Faraday and her colleagues, and you're about to see. These are all the known existing clusters. And through their research, they found this other single enormous association. And once time starts moving in a second, you're going to see a lot of stars move, and I'm out of time. Yeah, it's not worth it. People should ask questions. I'll just throw up another video. The other thing that's cool is like you can see stellar flybys in the past and future. So like in 1.3 million years, the solar system will have a second star in it. But read the paper. That has all the details.
Does anybody have any questions for Dan? And I'll bring you the microphone.
Sorry, I talked so fast. I had a lot to say.
What did you mean by that last comment about the sun? There'll be another star?
So what we're seeing right here is
Yeah.
you can see stellar flybys in the Gaia data. So we know that stars pass by each other. We don't 100% know the frequency of it. There have been some statistical analyses on it. But we know from proper motion analysis that about 70,000 years ago, a star called Scholz's star passed very close to the Oort cloud. Unfortunately, Scholz's star is not one of those measured by Gaia. And it's been suspected for a long time that this star, GLPA 710, is going to pass very close to the solar system. Based on Gaia measurements, we now know it's going to get within 20,000 AU of the solar system. It's going to pass inside the Oort cloud, only a little bit beyond the Kuiper belt, and this very faint red dwarf star will be a negative 2.2 magnitude star in our sky. It won't become part of the solar system. It will obviously cause some cometary disruptions, and this is important because this may be tied to extinction events. And also, one thing that I think was very cool that Faraday put it is like, if there are planets around GLPA 710, and if humans can make it 1.35 million years into the future, that's our best shot for interstellar travel. Like, it's gonna be a few years to get to another star. And I'm done.
Out of time. Thank you, Dan.
Thank you. Check out the paper in the proceedings. It has a lot more detail.
Next up, we have Chris Jansen talking about his Starship Bridge simulator, the next generation. So again, we'll give a warning at 2 minutes, a gentle warning, and then you have 10 minutes to speak. After that, we have 2 minutes for questions. Please wait for the microphone before you ask your question.
Okay. Good morning, everybody. Nice to be here. Thanks for coming to my paper talk. How many of you guys saw Artemis in the last, must have been 2 years ago, a couple of years we were at a workshop in the hospitality suite, we ran it. Yeah, you're smiling a little bit because it was a little more fun in the hospitality suite. We had to put Ron Proctor on depressants to calm him down, if you remember that. So the next question I have for you guys is, how many of you guys are sci-fi fans and you've always wanted to be on the bridge like Captain Kirk? I mean, yeah, come on. It's like, we've been doing this since we were kids. I set up a bridge in my basement when I was in middle school and all my friends came over, and it's been something of, I would rather almost do this than my real job. So it's hard for me to put this down when I'm here. So I'm here to talk about the next generation of Artemis and what has happened to Artemis. And we used Artemis for almost 3 years. We had to put it down, not like a dog, but we put it down. It's still running. It's many happy viewers. So what is the next generation? First questions we want to ask is, let's not make the tail wag the dog here. There's a cool piece of software, but why should you use it? Why play in your dome? you are the space place in your community. You're recognized as the space experts. People come to the planetarium for space knowledge and fun. And this gaming fits exactly into what our intended purpose is. Interactive games allow people to interact and be cooperative with each other and interact. And so it just fills special niches, like special events and things like that. And also, as we know, educators know, when people are having fun, they're learning more. It sticks. Okay, so Artemis it's still available. It's very cheap, $40 for a bridge. That's what we used for many years. We had a huge following. Every Tuesday night we met. We ended up with a group of 50 people that met almost every single Tuesday. They would show up, and it became like a family. It was crazy. And then one of the teachers left the district, and then we upgraded to stairs from a flat floor, and our computers had to be anyway. So we kind of just put it down. We had some problems with it. I'll explain. What is Artemis? For those of you guys who didn't raise your hands earlier, it is a bridge simulator. You basically have some PCs or computers set up with a main screen, a captain, and you have to solve problems commanding a ship working together. So you have a helmsman. If the helmsman doesn't know what they're doing, you're not going anywhere. If the engineer doesn't know how to distribute power, you're not going anywhere. If the weapons officer fires your last nuke by accident, you're going to be defenseless. It has happened. So here's some screenshots of Artemis. I had a student who just came back from Gen Con this summer. He's so excited, like first day of school. He runs in my office. He's like, "Oh, I was at Gen Con this summer, and they had a whole wing of the hotel with huge lines that were playing bridge simulators." Like, calm down, Michael. Calm down. And yeah, so people are doing this stuff all over. They're building custom bridges, and it's a huge deal for people all over the world. So we struggled. We wanted to rejuvenate the program. I had about 5 interested students at first, so we looked for software, and there was like 3 different titles we looked at. We downloaded and tried them all. We settled on Empty Epsilon for a couple of reasons. Why aren't we still playing Artemis? Artemis is closed source. It's very old. Doesn't even use OpenGL. Uses, well, anyway, it's an old graphics engine. The new one uses OpenGL. The communication was very laggy with Artemis, but we hooked up to 57 computers together with Empty Epsilon, and there wasn't a single bit of lag. The 3D format, you can just bring in OBJs with standard models. In Artemis, you had to use an old piece of software called DALED, which isn't being supported anymore. You used to use XMLs to write mission scripting, which you can't use variables, ifs, while loops, anything. So your missions were huge and abhorrently large with little power. Empty Epsilon uses Lua, open source, full programming language. So you can make some incredible missions. Artemis was very space arcadey, like Space Monsters, and those of us who want to do science education, it was really hard to explain what a space dragon is, and they really don't exist, kids, and I just started to get a little weird. Also, it's open up to Linux and Android as well. There was also no touchscreen support. I mean, if you're on the bridge of the Enterprise, I'm sorry, you got to have a touchscreen, right? You don't have to. You could use a mouse, but you know. Also, Artemis has a single projector for main screen, but Empty Epsilon is multi-coverage. Now, why is that important for us? Because you're in a dome. You want to utilize the real estate of your dome space. Well, do you see those 3 screens? Those are 3 average computer projectors and average computers, and you just assign the angle so you could have all the way around your head if you wanted to. You could have a 180-degree main screen pan in your dome, which utilizes the real estate of your space. Why don't I just play this at home? Because you don't have a dome with a 180-degree view, duh. You know, that's what you tell people. The other thing is it's open source and free. If it's open source and free, guess what you get to do? You get to have special events, and you get to charge, don't you? That's right. So Artemis, we always run into this problem of licensing, like, oh my God, you know, he probably isn't going to have a problem with this. We can ask permission, but if it's open source, go ahead, run a special event, run it in your museum. It's free. As long as you follow GNU rules, you're fine. So here's some main screens. Oh, it's hard to see. I guess it's better up here. Someone ridiculously took Artemis and they put it into this game and they posted screenshots and said, "Is it just me or does Artemis look better not in Artemis?" It was so. Anyway, so the main screen is built. These buttons you can kind of customize a little bit, but just to give you a flavor, there's nebulae, comms. Really cool things for Artemis players. That there's sensor shadows. We call it fog of war. Sensor shadows. You have to send probes inside nebulae and things like that. You have to do things in science, and you can set the difficulty. Really complex ships, you have to adjust wave patterns so they match before you can get data. You can also hack other people's ships, so you can order them to lower their shields. So here's tactical. Engineering, we can customize those ships and where the systems go inside of the ship. Self-destruct requires at least 3 bridge officers now they have to weigh in. It's kind of cool. Like as soon as one person activates it, another screen pops up. Do you approve? Enter your code. So I worked with a programming teacher at my school, a really neat guy, and he said, hey, I have an advanced programming class right before the holidays. We've got 5 days to kind of just spend on whatever we want. What do you want to do? And I said, well, we could do some Lua scripting, if while loops. And he goes, my God, let's do it. So he took his 2 classes, and we loaded up empty epsilon across here, and we had the kids just start coding. And in a matter of 5 days, they were making their own code. And this was I was recruiting at this time totally. So we had 5 interested kids, and at the end of this, we ended up with 12 students working in the planetarium. This was the 5 that kind of kicked it off, knocking on my door. We're Trek fans. We want to play. Okay, so how does this work? You can't have 50 kids coming every Tuesday or 50 people from the public. This has to pay for itself. It has to be something that's educationally valuable. It has to be financially valuable. So we thought we would use it as a escape room. How many of you guys are familiar with an escape room? Okay, yeah, it's like $30 to $50 you pay for this escape room for an hour, and you get with 6 or 8 friends or 10 friends, and you go to this thing, and everybody pays $30 each, and you have a blast. Why can't we do that with this? Why can't we have a Starship escape room where you get 6 or 8 friends together, and hey, I got a surprise for my family. I won't tell you till we get there. Oh, Thanksgiving, we're all going to head over, and surprise, we're going to command a Starship. Whoa, that's so cool. And can you complete the mission or not? You have to work together. Well, you, as a planetarium, have just fetched $200 to $300 for 2 hours in your dome. Helps pay for the hardware. When we buy a program, we spend upfront cash, thousands of dollars, in anticipation of reclaiming that cost. This is no different now. You put money into hardware, you then run your escape rooms, you then acquire those funds back. So that's kind of what we're thinking we'd like to do for the niche. So our intention is we'd like to create a single polished mission using NASA exoplanetary data, so when you're flying around the real universe, looking at real exoplanets with correct colors of stars and planetary orbits and things, in an escape room style feel, filling our educational and gaming niche that everyone can play. What do we need from you? Are you a sci-fi person? I already know you raise your hands. Too late now. If you have a meager PC or a couple PCs laying around, you don't need fancy gaming hardware, it's free. Just download and play and have fun. Give it to someone in your office and say, hey, you guys, you got to check this out. If it's a party and you've got some beers around, and just load it up on some PCs and have some fun. Better yet, do you know someone who likes to code? Send them chocolate and show them the game, because there are some things we want to change inside the game, but the source code is C++, and we're a little stuck. Is it okay if I go just 20 seconds in? So this is the last slide. It's called Empty Epsilon. If you Google search it, or you go to this website, you can download source code. If you want, you could begin playing it immediately. So I hope you join us. Join us. We need you. Thank you guys very much. Question? I have 1 minute, 30 seconds for questions.
Anyone have any questions? I'll pass the mic.
Are there any disadvantages of empty epsilon as compared to Artemis?
That's a good question. The disadvantages right now is the community is pretty small, and the scripting in XML is easier than Lua. So if you wanted to make basic missions, it's also older. So if you go to Artemis, you'll find a wealth of mission scripts that people have written. So if you go buy Artemis and start playing Artemis, you'll have play. But it's pretty basic. And MT Epsilon just is like, really in the last year, it's come together. So the mission script library is very low. And the creator, he's in the Netherlands, he's very responsive. I've worked with him already. He's already admitted he just doesn't care if it goes global. This is his passion. It's not a business for him. So he likes coding, and he writes it for his coding friends. And if you guys want to play and code it, have fun with it, he doesn't care if it becomes the next big thing. So he is not pushing people to write scripts like I would like to push people. So that's the major disadvantage.
This might be too technical. Our system, we've got projectors in different areas, but there's a physical mass that reduces the projection area. When you set up a multi-screen display, can you like size it down so that it would be able to work through a mass system like that?
Yeah, you pretty much, you aim the 3 projectors, you just adjust it, and you tell the computer, you're pointing at this angle, and you're pointed at that angle, and you can put them wherever up or down you want.
And we are at time, so hopefully you can ask Chris questions.
Yeah, please do.
If you see him, and which is Steve Crawford. So let's get set up. So we have a few minutes left in our introduction period, so we'll make sure to stay on time. For people who are switching between sessions, just a reminder, we have 10 minutes to speak. I'll give a warning at 8 minutes, and then we have 2 minutes for questions, and please wait for the microphone. And we'll let Steve take it away.
All right. Hello, everyone. My name is Steve. I work at the Kalamazoo Valley Museum in Kalamazoo, Michigan. This is actually my first GLPA, so I want to thank you all. It's been pretty fun. So I know there are already quite a few of you here who use and are pretty familiar with Git, but there may well be others who are not familiar with Git that could benefit from using it. We have benefited in our dome from using it in a number of ways. So Git is, first of all, a version control software. It allows you to do a number of things. You can track changes to code. You can revert back to previous, you can revert changes, so you can go back to previous versions of coding, and this can be pretty helpful if you manage to completely screw up a script and it looks nothing like it did, 2 hours ago when you started working on it. And you can just wipe all that and go back, but not lose everything. You don't have to start from scratch. You can go back to basically an earlier snapshot. I've started using Git with, we have a Digistar 6 system, and we do a lot of coding for that in the Digistar scripting language. And that can get a little hairy moving. We have a workstation up in our office, which is on the 3rd floor of our museum. And then, of course, we have the dome, which is down on the 1st floor. And typically what we do is put some script files on a flash drive, see if it works, and then maybe make changes down there, and then we end up with 8 different versions of the same file, and maybe some of them are upstairs and some of them are downstairs, and we can't remember what's upstairs. Did I make that change downstairs? Is it ready to go for the show? So one of the biggest reasons that I started using Git in our planetarium is not to track changes, but rather to have a really easy way to sync projects from our office to our dome and make sure that they're up to date and they're ready for whatever show we're doing. On tracking changes, you do have to get used to seeing a log of your failures, which can be helpful or frustrating. As you can see here, I forgot to have stars in my evening sky at one point for a program that I was working on. It is nice to be able to look at a log of what you have done and when you did it. It is a memory aid in that way also. Git is very flexible. In our planetarium, we have just a pretty simple setup. We have the workstation, we have the dome, and then I have set up a server just to host Git repositories. Repositories are the way that Git tracks a project. A repository is essentially a project. And so I have repositories for all of our shows that require scripting. And you don't need to have a separate server. You could just have it all on the dome. You could have it on one computer. It can be used locally. So if you don't have a lot of things, it can still be useful to track changes, though if possible, it is probably better to have that on a separate system, just as a way to back things up. And you can go the other way, of course, also. If we were much larger and we had a lot of workstations or multiple domes, this would, again, be a good way to keep all that organized well. And if you have multiple workstations with single users for each of those workstations, which we do not, we have 3 people using the same workstation, you can track who made what changes, and that way you know who to blame when everything goes wrong. Or not, if you're feeling magnanimous. But the point I would like to make is that Git is usable at all scales, and I think everyone can find some use out of it if they do any kind of scripting or programming in their planetarium. So I did run into a few problems using Git with Digistar. The biggest problem is that Digistar, for a reason that I've yet to figure out, but I'm hoping someone at ENS will be able to answer this at some point for me. Digistar, by default, encodes integrated script editor in UTF-16, or it says it does. I think it's actually slightly different, but regardless, Git reads those as binary files, and it can't quite track the changes. It can't show you the difference in the lines of your code. In the Digistar user preferences, you can change the encoding from UTF-16 to UTF-8, which is great, but then all of your scripts that you have created before then, we had, hundreds be re-encoded, basically. So I just set up a way to automatically re-encode those. then it works fine. Doesn't seem to be any difference between encoding in UTF-8 and UTF-16 in Digistar as far as the other problem, and it's not really a problem because Git has a great feature to solve this, is that any of you with Digistar systems know when you run a script, it generates a file, a .lis file. I have no use for. I don't need to track those. I don't need to keep those in my Git repository. You can set Git to ignore files of any type. Ignoring .lis files keeps things going a lot faster and things like that. I think I'm good. If anyone has any questions, I think I've said more or less all I need to say. So. Yes?
Hello, thank you. So the server that you have, is it storage as that server?
When you say cloud storage, what do you mean?
Do I have to buy a separate piece of hardware for my workstation DOM to talk together via Git to share?
Okay. If you have a workstation and the DOM, your workstation could be the server or the remote for the DOM. You can't use, when you say cloud storage, I think of things like Dropbox or Google Drive. That hardware, but I have I'm blanking on the word, I'm sorry. Machine, it's I bought server space basically for
Stephen, so I think version control is a super important thing that we generally do a terrible job with. So this is great. Why not use a service like GitHub?
That's a great question. For us, it is just because administrative hoops. You could use GitHub. GitHub, for those who don't know, is basically hosted Git storage. You absolutely could use GitHub. I would be fine with that, but the institution I work in is big and has a lot of decision makers, and I just thought it was easier to. I didn't.
So I don't actually have a question. I just want to say that I did this with Digital Sky a few years ago, and it made vast improvements to my quality of life. So if it seems at all intimidating, trust me, it is worth it. You should do it. I just wanted to echo that.
Last question.
Okay, I remember my other part. Is your synchronization routine manual or automatic? And if one, why not the other?
It's manual. I honestly had not considered making it automated, so I guess that's the answer to your second question of why. Just because I hadn't thought of it. But no, it's manual. You have to push things up to the remote server and then pull them down in the DOM. So, or vice versa, which is part of the great thing is that we can make changes in the DOM and then they show up on the workstation. So.
All right, thank you so much. Yes, thank you. And our last paper for this session will be Mark Reed speaking on the pursuit of a better mousetrap, constructing an effective analog monitor filter for a planetarium council. So we have a few minutes to get set up.
so I'm live.
All right, let's welcome Mark Reed.
Okay, well, thank you. I know that I have a mouthful with that, but the idea is pursuit of a better mousetrap is really, there are lots of ways in which people have constructed filters for their monitors to basically solve a number of needs. So I'm just going to kind of give you a little bit of historical roots of it. This was my first computer problem. It's an Apple IIgs. I used it in my classroom, and then it was taken over to the Hearst Planetarium, where I ran that with our East Coast automation system. But in a darkened room, the monitor was still too bright. Those early computers that all of us used in our planetariums, they were used primarily to automate different types of equipment. There were different types of ways in which people controlled the amount of light spill from these monitors. You could turn them off, because if everything was automated, it worked fairly well. You might have used red cellophane and tape to attach it to block out some of the light. Or you might have used some red plexiglass, and I brought one of my legacy pieces. Anyway, these things were used. They worked out pretty well for the jobs that needed to be done. Those automation systems, they were largely line text that could be used to control types of devices. We had SMPTE time code that would be used to control how those devices would work. But really got down to the end, you had line after line, just text. Some of the programs I remember writing were several hundred lines, up to 1,000 lines. And you could watch these while you were giving a planetarium program, but you really didn't need to that much. However, as things became more sophisticated, we had to be able to do more. But the real change had to do with full dome. And so I put up the term, it might be applicable for us here in our organization, BFD. It doesn't have a bad word in it, but it really means before full dome. There's those that have run slide projectors extensively, and then we've converted over to full dome, and there's probably some in here that haven't run the old automation systems with slides. So just with our talk, we have a diversity in our group here as well. Kind of a weird Venn diagram. When I was able to switch over to full dome, I had a window of time where I needed to run our classic slide projectors and with full dome. So I have the monitor in the middle that has the red screen in front of it, but you can also see the brightness from the monitors for full dome. In Jackson, I built a structure where it has, right at the very top here, it's very deep, so I could shield a lot of the light spill. And since I was kind of behind the dome itself, it didn't spill too much up onto it. It was that distracting. So that was one way that I dealt with it. And so this was in 2014. That is showing without the lights on. You can still see there's quite a bit of light spill, and even with the middle monitor, the red filter is off of it. But full dome has so much information, and for me, color is important because it's one way how I search for information and how I organize it. In 2016, I had the opportunity to go to Kalamazoo, and within the first week that I was there, I was asked to do an upgrade. And we had a Digistar 4 projector. I had an opportunity to replace it, start to look at all the other types of equipment that we had there, and to write a proposal that would take us essentially 10 years into the future. And so at the end of that project, we had 3 monitors on our desk, and they would spill a lot of light. This is showing what those monitors look like without any type of red setting or filtration in front of it. Notice the amount of glow just on the desk. It's a black surface. This is a Chroma Cove computer monitor right here, and two Digistar 6 system monitors. They're actually made by Dell. There was a red toggle setting in the Digistar software, and that's showing that in place. So that was one way we could deal with it, but everything's pretty much in red. And that's my coworker. Without any filters there, we looked like we were kind of glowing to our audience. And so we needed to do something. It was just simply too bright. Whether we were using red plastic or using other things. So I contacted a plastic company. I had two goals in mind. One, I wanted to display full color. The second was that I just wanted to reduce the amount of light spill. How much light was actually transmitted beyond the monitor. So one of the companies that I contacted was named ePlastic, and this address and information is in the proceedings. And through my conversation with them, and if you would like to buy some samples for a small fee, I can send you some. And I was able to get 5 shades, not a very big plate. 2 shades of gray and 3 shades of bronze. And they had different numbers, so what it meant is, because the slides really don't show it much justice, you can see through them, but also as I hold them, you can see that if they overlap, there's a different set of properties. So experimenting in the dome, I selected a couple that I thought would work. Now, one of the pieces of information that was important, it didn't matter whether it was an 1/8 inch thick or a 1/4 inch thick. The amount of light transmitted through it was the same percentage. Experiments in the dome, in the darkened room, allowed me to pick an optimum combination. And so those numbers, the specific ones are 2370 and 2074. You won't remember those, but in the proceedings you can get that information if you choose to order some. So when you order this material, you can get it in sheets 2 feet by 4 feet. You can have it cut to size. So I opted to say, well, I have 3 monitors. What size do I need? And I was able to figure out I could get 3 monitors out of one 2 by 4 foot sheet and still have some left over. Just know that it will also have some type of protective paper covering on that. That's good to know as you're constructing things, because it'll prevent you from scratching up the plastic. So how am I going to attach these to the monitors? Well, I decided to use some aluminum stock. I had some flat stock and I got some U-channel. U-channel had a 1/4 inch between, which made it very nice to be able to take and sandwich the pieces together to hold it. Now, to be able to fasten it to the monitor, what I really wanted to do was to be able to take and attach these two so that I had something that I could set over the back of the monitor and hold the plastic. You might want to, if you do this, you might want to get some clamps. Clamp it fairly often, but you can use some JB Weld to fasten it together. I've talked more about the construction within the paper itself. But here's kind of a cross section showing the plate and the U-channel, showing the top that rests on the back of on the top of the monitor and how it hangs over. Another quick view. And I'm actually installing it, and that's really hard to see, but here's what the finished product looks like. And you can see that it's very simple, and we can just hang it over the monitor like this. Now there's some things that you might want to do to be able to put a little Velcro on there so that it just doesn't slide off. The Velcro is more of a nuisance, but it really does a nice job. Whoops, I hit the wrong button. Okay, so this is, let me go back. It's showing our desk with the monitors on so they look attractive. Two of the filters on with one that's not filtered. And that's all three on. And so we can see in color, look at the desk. Do you see the two very much light spill?
Go into questions.
I can do that.
Okay.
We're very close. So the last thing I wanted to mention is that you can also toggle the red for those that want to see only red. So closing comments and questions. Come see the filters in action in Kalamazoo in 2020 when we host. If you would like to see what things look like, it's a little hard to see in this view here, but if you'd like to see that at the closing here, since I'm the last session, I'd be happy to share more with you. Thank you. Question?
Do you leave them on pretty much all the time, or you take them on and off when you're programming or not? And since they are such a large object, do you find them obtrusive to remove and put back on frequently, or?
They're very easy because all you're dealing with is just 2 pieces of Velcro. Just lift it off. We don't take them off very much, but sometimes when we're working, trying to program, we want a little more light, may take them off. But they seem to be working very well for us. My colleague Steve here may have a comment.
I was just going to say I'm pretty much the only person that takes them on and puts them back off. Much more often than the others, but for the most part, they don't really affect anything at all. So.
Any other questions? Yes, buddy.
Can you just switch back to the slide that had the numbers? I can write those down.
Okay. Yeah.
Like the numbers of the actual glass that you ordered.
Mm-hmm.
That's my whole question, Renee.
Final selection right there.
Yeah. Thanks.
It's a shade of bronze, 2370 and 2074. And again, in the proceedings, some tips about when you're drilling the material, what size materials to buy. Okay. Yes.
Can you give the the cost of that sheet, and then also what kind of that plastic with?
I ordered it pre-cut, so I didn't have to do that. But I didn't want to have to hassle with trying to find a table saw to do it with. Plus, I wouldn't have to worry about chipping it. The one thing I'd recommend is that when you drill through the plastic edge, so you want to have a small bit to drill it with, have it be a sharp bit, and then drill the plastic holes a little bit oversized compared to the bolt holes, because you don't have. The other thing I did here too is I put a little Velcro over the nuts on it, so that I'm not scratching the monitor. The other thing, by having some Velcro at the top, and it's not going to slide or pull off to where it can damage your monitor. But it's just basically enough Velcro to be a nuisance till it comes off very quickly and easily. Cost, I don't recall specifically. I could get that for you if you want to write to me. I want to say that we had about $100 in the plastic that we bought. But we're equipping 3 monitors. And there's sheets for each. I think the labor cost was $18 to get this material cut. If you're ordering plastic, it's going to come in a company called ePlastic.